Hi, I'm Dr. J, and this is a video about the Monte Hall problem. The Monte Hall problem is named after a game show started in the 1960s called Let's Make a Deal and hosted by Monte Hall. The gist of the game show is that a contestant is brought up on the stage. They're shown three doors, those three doors represented by the three cups here. They're told that behind one of the three doors is a grand prize, and behind the other two, essentially nothing. Now, the contestant is asked to choose one of the three doors. Go ahead, right now. You can choose one of the three doors. Any of the doors you want. You can choose any of these, cups. Yes, they are cups. They're not doors. So you can choose any of these three cups that you want, any of them at all, right? I'll even turn and look away. Oh, you want to choose the Frozen Anna Elsa cup? Great. All right, so you've now chosen this cup. Maybe I should pull it back instead because I'm not doing anything fancy here. And now what happens on the game show is that Monte Hall will reveal what's behind one of the other two doors. And so I will reveal what's behind one of these two cups. So I will choose this cup, and you'll notice that there's nothing behind this cup. So that is not the grand prize. And now Monte Hall will ask you whether you want to stay with the original guess or you want to switch to the other unopened door. Now, if you haven't seen the Monte Hall problem before, or even if you have and don't quite remember how it works, you should take a moment right now, maybe pause the video even, and try to guess no, let's not say guess, let's say try to determine what the probability is of winning if you stay with your original cup, or if you switch to the new cup. Okay, so go ahead, take a few moments to figure it out. I'll just sit here. Okay, I'm not really going to just sit here. So what I want you to be thinking about is determining that probability. Now, at first glance, and when people try to do this sort of intuitively, at least in one way, you are often getting to the wrong answer. So most people get the right answer for the first piece. That is, for the first cup you choose, that is, if you stay with the original guess, the probability is 1/3. Because when you look at these three cups, they're all equally likely to contain the grand prize, and therefore whichever one you choose has a 1/3 probability of actually having that grand prize. So when you choose this purple cup, the probability of getting the grand prize, even after another door is shown, is still 1/3. That hasn't changed even though we've shown you another door. Okay, but what does change, or what's kind of more interesting, is if we've shown you this door, and now you say, what's the probability of winning if you switch cups? One sort of knee-jerk intuitive answer is to say, well, it's now 50-50, because it could be behind either of these two doors. And on the surface, that seems very plausible. It turns out that that's not correct, which is what makes this an interesting probability question. Okay, and so to demonstrate why that doesn't work, I'm going to switch cups. So I'm going to go from these colored and importantly opaque cups to a set of clear cups, so you can see exactly what's happening. Oh, that's the first time we've seen the grand prize. The grand prize here is a vanilla buttercream candle. Not quite what you would have gotten on the game show, but nice nonetheless. And it happened to have been under the purple cup originally. But now we are just going to show what happens as you think about where the grand prize is and whether you should stay or you should switch. And so, for the moment, we will keep the grand prize under the rightmost cup, at least on my right-hand side. And I will ask you again to choose any cup. And at this point, the grand prize could have been anywhere. So it had 1/3 probability of being in the right cup, or cup on my right, 1/3 of being in the center cup, and 1/3 of being in the left cup. And therefore, no matter what cup you choose, you have a 1/3 probability of actually getting the cup with the grand prize. Okay, so had you chosen this cup, I reveal a cup, maybe this one, maybe the center one, and now if you stayed with the original guess rather than switching, right, you would have won the grand prize, but the probability the whole time was 1/3 that was the case. Okay, now imagine the grand prize had been somewhere else, and this is where things get a bit more interesting. And just for simplicity, we're going to say that you've still chosen the cup on my right. Okay, so now when you've chosen the cup on my right, And so it's now sort of out of contention, and Monte Hall has to choose which of the two cups or doors to show you. They're never going to show you the cup that actually has the grand prize, because what kind of game show would that be if they're now asking you to choose between these two doors when you know that neither of them have the grand prize? It'd be pretty boring. So instead, they're going to show you a door that does not have the grand prize. So they're going to reveal nothing under this cup, and they're going to ask you, do you want to stay with your original guess, or do you want to switch to the other unopened door or the other unflipped cup? Okay. If you switch to the unflipped cup, then now you would have won, right? Okay. And the same thing is true if the grand prize had been under the other cup. Right? So if it was under this cup, you've chosen the first cup, the cup on my right. I have revealed the cup in the middle because it does not have the grand prize. And now if you switch, you are going to win the grand prize. And so the key here is the fact that if you happen to choose a cup that does not have the grand prize originally, what's the probability of that? The probability of winning the grand prize originally, or picking a cup without the grand prize originally, is 2/3, because there are 2 out of the 3 cups that don't have the prize. Now, if you choose one of those cups that doesn't have the grand prize, right, and another cup is revealed, now you are guaranteed to win the grand prize if you switch. Regardless of where that grand prize had been, you would now be guaranteed to win. Okay? So the key in this game is to choose a door that does not have the grand prize. And the probability of choosing the door that does not have the grand prize is 2/3. Okay? So the probability of choosing the grand prize if you stay with your original guess is 1/3. The probability of winning the grand prize if you switch is 2/3, because you had a 2/3 chance of choosing a cup without the grand prize, meaning that another cup without the grand prize has to be revealed, in which case if you switch, you are guaranteed the win once you have chosen a door that does not have the grand prize. So just to recap, right, it's always beneficial to switch. It's beneficial to switch because if you stay with your original guess, the probability of winning is 1/3. If you switch to your new cup, the probability of winning is 2/3. Okay. I hope you enjoyed this video. If you like these kind of things, go ahead and like and subscribe. If you have questions about this probability calculation, right, I've done this without any math and just trying to do it intuitively based on visualization of what's going on. But if you have any questions, go ahead and put them in the comments down below. Otherwise, if you have suggestions for future videos, perhaps related to probability results that don't make sense to you, go ahead and put those also as a comment down in the description, and I'll consider making a video on that in the future. Until next time, hope you have a good one.